Wheels, they are an important part of any combat robot, and for the longest time I have been casting and molding my own silicon wheels, which is a fairly time-intensive and laborious process. Today we ask, has it been worth it? Hello everybody, I am Ben from Team Panic. Diagonal one. A little while ago, we did some testing on N20 motors, looking at the 30:1, the 50:1, and the 75:1 motors based on their speed, their drivability, and how much traction they had against the floor of an arena set up as a 150-gram robot. And today we're going back to that traction testing to look this time at wheels. And we have kind of 5 competitors to look at today. First up, we have the Pololu wheels. These are fairly cheap and readily available online from Pololu themselves, and then also from a bunch of clone manufacturers in China and a bunch of other places like that. They're fairly inexpensive and are a decent way into the sport to just get going with an ant weight. Next up, we have the silicon wheels that I mold and build myself. As mentioned in the intro, these things take time to do. You need to set up the mold, you need to 3D print a bunch of stuff, you need to spend the time casting, molding, and then letting them cure and actually get ready for an event. And then finally, we have the last category, which is a kind of 3-way category, which is hubs that use O-rings instead. And we're gonna do 3 different variations of these. 2 O-ring version, we have a 3 O-ring version, and we have a 4 O-ring version. So we are going to look at all of these in turn, look at their weight, and look at how much traction they have. And we're gonna work out fairly definitively, at least a little definitively, how well these silicon wheels that I've been making for a while stack up. It's time to look at the weight, with a pair of Pololus coming in at 10 grams, a pair of my silicon wheels coming in at 23 grams, a pair with 2 O-rings coming in at 20 grams, a pair with 3 O-rings coming in at 22 grams, and a pair with 4 O-rings coming in at 25 grams. Which honestly surprises me just a little bit. I thought that my silicon wheels were going to be the heaviest by a long shot in this lineup, but they really weren't. And in fact, the grip area between them and the 4 O-ring system is around about the same, but the 4 O-ring system is just that little bit heavier, which is interesting. Now we are on to the traction test, and we're going to do this the same way that we did the traction test with the gear ratio N20s in the last video, except for this time we have the whole setup on a bit of an angle, because last time everything shifted one way or the other, and this time round, hopefully, this angle will keep us pointed in the right direction. And to the results. The Pololus came in with an average pull force of 109 grams. My silicon wheels came in with an average pull force of 77 grams. 2 O-rings came in with an average pull force of 96 grams. 3 O-rings came in with an average pull force of 90 grams. And 4 O-rings came in with an average pull force of 90 grams. So that is interesting. By everything that I thought I knew, the silicon wheel should have blitzed this competition no problem. And instead, we are sitting in last place with the Pololus in first, which doesn't make a lot of logical sense to me, because the amount of tire that you have on the ground drastically increases the amount of torque you should be able to get out of the system. given that you have ideal grippiness and all of that kind of stuff. So the fact that my silicon wheels are twice the thickness of those Pololu wheels should mean that they should be making so much more contact, they should be pushing so much more torque through the robot and through the ground, into the ground, and that's just not what the scale shows. I think, as I mentioned last time, this is something to do with the bounce. You see in all of the kind of slow-mo clips there that the O-rings and the Pololu wheels skidded on the MDF surface here and didn't bounce, whereas the silicon wheels did bounce. And this might be to do with the grooving that I have in the silicon wheels, causing it to bounce all over the place. And those bounces are losing traction with the ground, allowing the wheels to speed up and just kind of making the whole system worse, essentially. So I think it's worth doing this test again in the near future with a full set of different silicon ones with full flat patch, some grooves like I've currently got, a different set of grooves, and I might even throw this open to you. What do you think is going to be a good traction pattern on the actual wheel itself to get the most traction out of this system? I also think that going through into the next variation, we need a better setup for the actual robot platform that we're using. This one with the two wheels and a skid is okay, but not great. The fact that I have to tape weight to the top of it to make it to 150 grams is really not great. I'd like to build something a little bit different that I can bolt the weight into properly and have everything a little bit more secure so it doesn't kind of shake around all over the place. Yeah, anyway, that was really interesting. It was also quite interesting for me to note that adding an extra O-ring on after 3 didn't actually give you more torque out of the system. It kind of seems like you get to a point with O-rings where adding more is not going to help from there on out. So that's a good little weight saving tip if you are going to use O-rings for wheels. 2 or 3, probably the maximum you want to go. 4 and above, it seems like you're actually getting diminishing returns on the amount of weight you're stacking onto your wheels. So that was interesting. Lots of little things that are just kind of interesting tidbits for us to explore further in the future. Anyway, I hope you've all enjoyed that one, and I will see you in the next video.